Hello everyone, my name is Ju. I'm working for ADVA Optical Networking in Munich in Germany. Today I'm going to present our paper on the secure open fronthaul for 5G networks. This is joint work with my colleague Andrew Sergeev from Israel. So the motivation of our work is to investigate the security of ORAN. ORAN stands for the Open Radio Access Network. It's an alliance by multiple companies targeting to standardize the interface and then network functions for the radio access network. So there are two main features, openness and disaggregations. The openness mode is targeting to provide more transparent than the proprietary black box implementations. Therefore, this is aligned with security standards and best practice. And disaggregation means all network functions are divided into the microservices. So the hardware resources are isolated. Therefore, this is automatically reconfigured, and the security is automatically tested. So it may create new vulnerabilities and also the security management issue that we are going to investigate in this paper. This is a logical architecture of ORAN system. It is composed of multiple interfaces and multiple functions. And our paper is targeting to see among those open fronthaul interface between radio unit and then device unit. There are two plane. One is CUS plane. The other is M plane. CUS plane for control user synchronization plane, and M plane for management plane. So this is our fronthaul model. So imagine there are multiple radio units with antenna collecting the user data, and they are delivered to the distributed unit via the multiplexer. In this case, it's important to provide security between the radio unit and the distributed unit, because sometimes fronthaul network is deployed in unsafe domain. So we are going to actually propose to implement the Informal Key Exchange. Of course, it's not necessarily ephemeral, but it provides more higher security level. So each radio unit and multiplexer have say P2MP key exchange and encryption, and then this key exchange, individual keys feed into the AES encryption engine, so data is encrypted with the single AES engine. Here is open fronthaul protocol stack. So M plane and CU plane, S plane are different stack. So M plane is higher level is netconf based on the SSH, but whereas CU plane has the EC3 protocol, and the other over the Ethernet layer. So this is a summary of security mechanisms in open fronthaul. The M plane, because of the protocol stack, security protocol is based on SSH v2 and TLS, whereas the CUS plane doesn't define any security protocol in the specification yet. I guess this is kind of concerned about the latency, because latency is so important for the fronthaul interface. So the security protocol is not defined yet. The M-plane is provide the full feature of security because the latency is not that critical. So for encryption, AES, integrity, HMAC, authentication, the RSA 2000 bit. We think the US plane also provides certain level of security to protect the important message. In particular, control plane, as I mentioned below, some ECP messages delivered critical information like reset command, real-time control information. So we propose to use MACsec with Informal Key Exchange, which is very fast in Ethernet layer with a minimum overhead. And user plane, the security is already provided in the higher level, like PTCP protocol. But we propose a MACsec authentication only mode, which provide the remote origin authentication. So here is ECPRI. ECPRI is again another standard the interface for Fronthaul. It already has security protocol as an option. This is not mandatory protocol, but it can be provided optionally, which is the IPsec and the MACsec. And so this is our proposal is well aligned with ECPRI specification. So MACsec is basically based on the Ethernet plane with minimum overhead, additional overhead, which is SecTech and the ICV. It could be 1616, so it's 32 byte, or optionally it's 8 to 16, so 24 byte. So MACsec and IPsec, which one is better? Is for the Fronthaul, it's difficult to say. But MACsec is based on layer 2 and it's simple and fast with minimum overhead and usually based on the hardware chipset. So its encryption is very fast. But downside is that it's hop by hop encryption. Normally there is a switch in between, then MACsec frame may not travel over the switch. Whereas the IPsec is standard already in 3GPP and widely deployed. So it's no problem to make a tunnel. Problem is that it's relatively complex. If you have installed the IPsec on your device, you may see how many options, how many parameters are there. So it's not, general security protocol is not dedicated for speed connection. Okay, here is the comparison of the throughput of MACsec and IPsec. If you see in the left side, it's with a small packet size, the speed difference is quite big, almost double. Whereas the large packet size, the difference is not too big. So we use MACsec DPTK technique. DPTK technique is more like accelerating the packet filtering. So we found out the MACsec software, and in addition to DPTK, throughput is almost same as MACsec hardware. The secure tunneling option, why we in the secure tunneling? Because Open Fronthaul also may deploy not directly over Ethernet connection. It may connect it through the multiple switches or routers. In this case, MACsec may not be recognized and may be rejected. That's why we need to make a tunnel. Here, MACsec over VLAN is one single technique. The second is MACsec over VXLAN. using the UDP overhead. So in the ESP Fronthaul packet is actually embedded into the encrypted payload. So basically MACsec frame is here, and then ESP common header plus payload ESP packet is embedded into the payload. So altogether 24 bytes, and MACsec VLAN is with VLAN tag is 28 bytes. And this is MACsec VXLAN. Is of course we need to add the UDP overhead, so it increased quite large, 74 bytes. So we have experiment on the MACsec over MACsec with VXLAN over the Munich and Tel Aviv site. Actually, this is quite too big. I mean, too large for the Fronthaul. But we just tested this MACsec with the VXLAN over multiple variants of the switches, whether VXLAN really can reach the destination. And we tested with this structure, and we actually performed the experiment between the Tel Aviv and Munich site with MACsec with VXLAN, and it passed 11 IP hops over the public IP network, and so we are successfully established the MACsec with VXLAN tunnel. Okay, so the latency and the distance is the important issue on the Fronthaul. So so far, based on the literature, Fronthaul latency budget for best performance is actually around 100 microsecond. And then, so we have to do a security protocol and encryption-decryption processing, and within the budget of 100 microsecond. So let's say latency typical processing time for RF and EC3, and then that is DU. And Fronthaul equipment processing delay is around 4 microseconds. Let's say encryption decryption processing time is a variable T. Then by this calculation, you can estimate the distance of the RU and DU based on this encryption decryption processing time. So this one is depends on your hardware processing computing power, or whether this is implemented in software and implemented in hardware. They are all different depending on the implementation. So for our experiment in our devices, the encryption decryption time takes around 34 microseconds. So if we add it here in this formula, in this case the distance would be 17.8 kilometer, which means that if this RU and DU distance around 17 kilometer, then we can imagine you can get the latency less than the 100 microsecond. So kind of this is maximum allowed distance. Okay, in summary, we realized that challenging to design the security measure Fronthaul interface because of the latency. Performance is very important. So we proposed MACsec and Informal Key Exchange may have potential to provide security services for Fronthaul, and in future we plan to compare our solution with the IPsec and also WireGuard, which is another efficient non-standard method in terms of security performance. Our work is based on the affordable 5G project, 5G complete project, and also the Quasi-Mode project. Thank you very much for your attention.